Alright, my friends, today is fraction mixed review. So you're going to see a number of problems that are all just review problems from our fraction unit. So let's take a look at number 1. Number 1, a rectangle is partitioned as shown. Which fraction, here's our question, of the rectangle is shaded? So it's asking you for shaded. Look at the answer choices. A, 1/8, B, 1/4, C, 3/4, and D, 4/3. So pause this video now and solve which fraction of the rectangle is shaded. Alright, we are back. So let's see if you were correct. So first what I want to take a look at is the fraction that's even given to us. This shape right here. I just want to figure out what fraction is given to us. So let's first figure out the denominator. The denominator is the number of parts in one whole. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. The number of parts in the whole are 8. 8 equal parts. Now let's figure out the numerator. The numerator is the number of parts that we're talking about, and in this case, it's the number of parts that are shaded. 1, 2, 3, 4, 5, and 6. So right now, our fraction that's represented is 6 out of 8. Now, what I'm noticing here is that 6 out of 8 is not even represented in the answer choices. So when this happens, I don't want you to panic. You need to choose the fraction that is equivalent. That is equivalent. Equivalent. Perfect. So, right off the bat, let's take a look. 6/8 compared to 1/8. Well, how do I get from 6 to 1? I divide it by 6. What about 8? Nope, that doesn't make sense. Alright, 1/4. 1/4 equals 6/8. How do I get from 1 to 6? Times 6. How do I get from 4 to 8? Times 2. Oh, that doesn't match. Alright, next, 3/4 equals 6/8. How do I get from 3 to 6? Times 2. How do I get from 4 to 8? Times 2. Oh, we have a match. That's definitely a possibility. Now, 6/8 and 4/3. How do I get from 6 to 4? Can't really do that. How do I get from 8 to 3? Can't really do that either. So the best answer, the equivalent, is 6/8. Another way you can do it is to draw fraction bars. Some of you may have done that. Alright, let's take a look at number 2. This looks super similar, but the question is slightly different. A rectangle is partitioned as shown. Which fraction, there's our question, of the rectangle is unshaded? This part is asking us for unshaded. So pause this video now and look at the answer choices. Which fraction of this rectangle is unshaded? Good luck. Alright, we are back. So just like our last fraction, we need to figure out which fraction is unshaded, which fraction is even represented. So first, let's take a look at the denominator. How many pieces are there in all? 1, 2, 3, 4, 5, 6, 7, and 8. So there's 8 pieces in all. And what fraction are we talking about? Well, right now we are talking about unshaded. So 1, 2. Easy. Now, I'm noticing again that 2/8 is not being represented here. So let's look at all the answer choices. Alright, 6/8 equals 2/8. How do I get from 2 to 6? Times 3. How do I get from 8 to 8? Times 1. Doesn't match. 2/8 equals 1/8. How do I get from 2 to 1? Divided by 2. How do I get from 8 to 8? Times 1. No match. No luck. Alright, 2/8 equals 1/4. How do I get from 2 to 1? Divided by 2. How do I get from 8 to 4? Divided by 2. Oh, there's a match. Let's take a look at our last one to make sure. Alright, how do I get from 2 to 2? Times 1. How do I get from 8 to 6? I don't know. So the best answer should have been 1/4. If you drew a fraction bar, that is totally fine. Nice job. Next one, this problem looks deceptively easy. Which fraction is equivalent to 8? Which fraction is equivalent to 8? So I want you to go ahead and solve. Good luck. All right, let's see if you were right. 8. 8 is the same thing as 8 wholes. So one way we can look at it is 1 whole, that's 1 over 1. 2 wholes, 2 over 1. 3 wholes, 3 over 1. You see where I'm going. 4 wholes, 4 over 1. But I'm going to do the whole thing. 5 wholes, 5 over 1. 6 wholes, 6 over 1. 7, 7 over 1. 8, 8 over 1. It's that tricky little rule that we had. That's just putting it over 1. This is equal to 0. Wrong. This, let me do this in a different color. This is looking at 1 whole and splitting it into 8 equal pieces. Wrong. This is having 1 whole splitting into 8 equal pieces, like the top one, and sheeting it all. Wrong. This is the only one that matches 8 wholes. All right, let's take a look at this one. By now, I hope you've gotten it. Please don't get this wrong, the EOG. Which fraction is equivalent to 6? Get to work. All right, so, if you hadn't gotten it yet, put it over 1. Why are you still getting this wrong if you got it wrong? Not hard. This is another way to write 1. All right, let's take a look at a fraction number line. So this question is asking us, what is the distance, the fractional distance between the star and the circle? Go ahead and solve. Good luck. All right, we are back. So the first thing we need to do is figure out how many jumps there are even in all. So let's go ahead and count. 1, 2, 3, 4, 5, and 6. There are 6 jumps. So if I took 1 jump, each jump is worth 1 over 6. This jump is worth 1 over 6. This jump is worth 1 over 6. This jump's worth 1 over 6. So let's go ahead and count how many 1 over 6 jumps it takes to get from the star to the circle. And I'm going to do this in a different color so I don't get confused. 1 6, 2 6, 3 6. So the answer is 3 over 6. That's the distance between the star and the circle. Good job. All right, last but not least, this is the same question. The circle and the star have just moved a little. What is the distance between the star and the circle? Go ahead and solve. Good luck. All right, let's take a look. So once again, 1, 2, 3, 4, 5, and 6. So the distance for each jump, one jump would be 1 over 6. So let's count how many 1/6 jumps there should be between the star and the circle. 1/6, 2 6, that should be a 2, 3 6, 4 6. That was so easy. The distance between the star and the circle is 4 over 6. Good job.